for number 8, we want to verify theorem 1.2.2, which is checking whether these propositions are equivalent. So I've gone ahead and I've filled in the truth table for P, Q, not P and not Q, because we know how to do that. That's pretty easy. Now let's fill these in. So for item A, we have not P or Q, right? So we're doing the disjunction of the third column with the second column. So we have true or false, which is true, false or false, false, true or true, true, and then false or true, true. So, and then now we're doing if P, then Q. So we're doing the conditional of the first and the second column. So if true, then true, that is true. If true, then false. This is false because it's the only case where we break our promise. If false, true, that is true because whenever the antecedent is false, the conditional is false. And once more, for the last row, the antecedent is false, and therefore this is automatically true. So we can see that the truth table of these statements are the same. Therefore, P implies Q is equivalent to not P or Q. So we'll just put a little check mark there for A. Now let's do B. So for B, we do need to do this auxiliary statement, Q, if Q then P, just so that we can build up our more complicated one. So let's do that. We're doing the conditional of the second column with the first column. So if true, then true, true. If false, then true, true. The antecedent is false. If true, then false, that is false. And lastly, if false, then false, so true, right? This is our truth table for if Q, then P. So now we're ready to fill in B. So B is just the conjunction of, it's the conjunction of, let's see, if P then Q, so of this column over here, which is our fifth column, and our sixth column, if Q then P. So we're doing the conjunction, so we're doing and. So true and true gives us true, false and true gives us false, true and false gives us false, and true gives us true. All right, now let's do the biconditional, Q if and only if P, of the first and second column. Now the biconditional is true whenever P and Q have the same truth value, so they're either both true or they're either both false, because it's a promise, that if Q is true, then P must be true and vice versa. If P and Q have different truth values, it's false. So we have true, which is true, then we have true, false, so false because opposing truth values, same thing. False, true is false because opposing, and then false, false becomes true because they have the same, right? So if we look here, the truth values, the truth table of P implies Q and Q implies P is the same truth table for Q if and only if P. Therefore, these statements are logically equivalent. We'll just put a check mark here. Now let's do item C, right? So we're doing not P implies Q. So we are negating, let's see, which column are we negating? We're negating this column over here. So we're doing not column number, let's see, number 6. So whenever we have true, we're going to put false. And then whenever we have false, we're going to put true, and then true, false, and then true, false. So we have negated P implies Q. And now let's do P and not Q. So we're doing the conjunction of the first column with the fourth. So let's do that conjunction. So true and false is false. True and true is true. False and false is false. And false and true is false. So once more, we can see that not P implies Q is logically equivalent to P and not Q, right? So we'll put a check mark. And now let's do item D. So we're doing not P and Q, and then we're doing P implies not Q. So let's do the conjunction. I forgot to do the auxiliary table here. So maybe we'll build that in. Let me build up an auxiliary table. Yeah. So I'm just gonna build it here. Let's see. So this is our P and Q. So for this one, let's do the conjunction of the first and the second column. So true and true gives us true. True and false gives us false. False and true gives us false. And false gives us false. So now for item D, we're doing not P and Q. So for item D, we are negating this column that we just created. So let's negate that. So not true is false, not false is true, and so on. Now let's do P implies not Q. So right now we are doing a conditional of the first column with the fourth column, yeah. So if P is true and not Q is false, then we begin by breaking a promise, right? Because the promise that if P is true, then not Q must be true. So if not Q is false, we have broken our promise, and then we have false. And now if true, then true, that clearly is true. And for the last two rows, the antecedent P is always false. So whenever the antecedent is false, the conditional is automatically true. So as we can see here, these truth tables do match. So not P and Q is equivalent to if P, then not Q. So let's just put a little check mark here. Now let's do, oh, this resolution here is terrible, but we'll work with it. So now let's do item E, and let me see if I can restore this resolution. Let's see. Yes, I can. Now I'm just going to kind of scroll down and fix these mistakes that I've made in the formatting. So let me just move this down. Weirdly it's not letting me. Oh, there it goes. Okay. So for this one, I've gone ahead and I've filled in our truth values for P, Q, and R. Now we do have 3 propositions, right? So we must have 8 lines so that we can account for all of their combinations. So remember that we're going to have 2 to the power of 3 lines, which is equal to 8, right? So I filled these in, and now let's construct the auxiliary table so that we can build our more complicated statements. So we'll do the conditional of the second column with the third. So true implies true, that is true. True implies false is false. False implies true is true because antecedent is false. False implies false is true. True implies true is true. True implies false is false. False implies true is true. And false implies false is true. Now let's do, for the next one, P and Q. So we're doing the conjunction of the first and the second column. So for this one, let's see. We're going to have true and true is true. True, true, true. True and false is false. True and false is false. False, true, false. Whenever we have false, right, because we're doing the conjunction, the and statement becomes automatically false. So we'll have a bunch of false ones. All right. Now we're doing P implies Q implies R. So what we're really doing now is a conditional for E, is a conditional where the first column here is the antecedent and the fourth column is the consequent. So let's do that. So true implies true, that is true. True implies false, that is false. True implies true, true. True implies true is true. False implies true is true. False implies false, true. False implies true, true. And once more, false implies true is true. And let's do the now a conditional for also E of P and Q implies R. So now our antecedent is this column over here, and our consequent is the fifth column, and our consequent is the third column. So true implies true. Remember, their antecedent is this column over here, the fifth one. So true implies true is true. True implies false is false. Let's see. False implies true is true. False implies false is also true. Now, the rest of these are all false, right? All false for the antecedent. So whenever we have a false in the antecedent, we know that the conditional is automatically true. So we'll go ahead and just kind of put true for all of these because P and Q is false, right? So we can see that these truth tables match. They're almost all true except for this line here, except for the second line, right? So we have proved that the statements P implies Q implies R is logically equivalent to P and Q implies R. So let's put a little check mark next to E. And lastly, we'll do, item F. So for item F, once more, we do have to build these auxiliary statements just so that it's easier for us and we don't make any mistakes. So now we're doing the conjunction of Q and R, so the conjunction of the second and the third column. So that is true and true is true, true and false is false, false and true is false. Whenever we see a false, we're just going to put false, right? Because it's a conjunction, true, 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 and then everything else has a false in it in some point, so we'll put false. Now let's do P implies R, so a conditional where the antecedent is the first column and the consequent is the third column. So we'll do here true implies true is true, true implies false is false, right? Because in that case we've broken the promise. True implies true is true, true implies false is false, and now for the rest of these, P is always false, so whenever the antecedent is false, we're going to put that the conditional statement is always true. All right, and now let's do P implies Q. So once more, the antecedent is the first column, and now the consequent is the second column. So true implies true is true, true implies true is true, true implies false is false, true implies false is false, and once more, we'll just put true for the rest of these because the antecedent P is false. Now we're ready to do item F, right? So for item F, we do have a conditional statement. P implies Q and R. So the antecedent is the first column, and the consequent is this column over here that we created, right? So let's do true implies true is true. Actually, I'll do this in a dark color that we can see. True. True implies false is false. True implies false is false. Let's see what else we have. And then we have true implies false is false. And now the rest of these are all true because P is false. Okay, now let's do P implies Q and P implies R. So we're doing a conjunction of, of these two columns, right? We're doing a conjunction of these. So, I have here true and true is true, false and true is false, true and false is false, false and false is false, and now true and true, and all of these are true, right? Because both of them are true. So once more, we can see that the truth tables match, and we can say that the statement P implies Q and R is logically equivalent to P implies Q and P implies R. So we'll go ahead and we'll put a little check mark here. I'll just zoom out so you guys can take a full look at it. And that's it for our problem.